Hello everyone and welcome to another screencast. I'm going to be screencasting Codechef Starters 17 and let's begin. I'm in Division 1. So Sasuke and Itachi Naruto are playing a game. Sasuke first creates an array A containing n integers, then creates a new array B of length n such that Bi is GCD of prefix. For each I, gives array B to Itachi and asks him to find any array A such that the given process applied to A will produce B. We just want to reconstruct array A. So to do this, first of all, if this is the array, right? Let's say this is the array. Then if this is B1, right? B2 must be a factor of B1. B3 must be a factor of B2 and B4 must be a factor of B3, because let's say it's like this: A1, A2, A3, A4. If A1, A2, A3 gives a GCD G, then A1, A2, A3, A4 will give something G by K, where K is a constant and also a factor of G. So that is the observation we need. And then how to build an array like that? We can we just output array B? We can just output array B. Does it not need be equal to A? So let's see. A1 equals to B1, A2 can be just B2, A3 can be B3. We just want Bi to divide Bi minus 1. And then we can just output B. What problem is this? Last div1 B, I think. So let's take in some input. Let me fix everything. I have everything as I like it. Please subscribe and let's get started. Vector A, I'm just gonna call it A, who cares, right? For integer I equals to 1, I certainly don't care. What I want is AI minus, modulo AI. If it is not divisible, then I'm gonna return while printing -1. Otherwise, I'm just gonna print A. What are they gonna do about it? Nothing. That's what I thought. Did they say anywhere though that A cannot be equals to B? Because that would be awkward. Nah, they didn't never mention that. So we are good. Alright, C++ 17, let's submit. And while we wait, let's go to binary inversion. It will be really awkward if I get a WA after opening the next problem, so please get AC. Come on, yeah, simple. So you're given n binary strings, S1, S2, Sn, each of length m. You want to concatenate all n strings in some order to form a single large string of length n times m. Obviously, that would be the length. Find the minimum possible number of inversions. So we want as many zeros to be on the left and as many ones on the right. Right, because what an inversion basically means is, let's have an array, right? And these are two indices, I and j. So if ai is greater than aj, but I is less than j, that is, what is this now? Don't reveal anything. I is less than j, and then this is an inversion. Basically, in layman terms, if a smaller number appears before a bigger number, then that counts as +1 inversion. So what can be the maximum number of inversions? You guessed it, nn-1/2 once array is sorted in decreasing order. So what do we have here? An inversion of a binary string such that I is less than j. Yeah. This is the same definition given. So yeah, this has 3 inversions. Inversion number 1 is these two. Inversion number 2 is these two, and then 3 is these two. So we want to concatenate these arrays. These strings. How am I going to concatenate? Hmm. Hmm. First of all, one thing notice that if a string contains only 0, I'm gonna put it on the left side, okay? So that I only get 0 0 0s in the left as much as possible. And if a string only contains 1, I'm gonna put it on the right. Okay, now what is gonna be in between here? So let's say I have a string like this and a string like this. So here, what I want to minimize is the number of ones multiplied by number of zeros. Okay. See, I cannot do anything about the innate ordering of any binary string, right? So all I can care about is okay, so all I can do something about is the way they are placed, in the order they are placed in. So all I care about is the number of zeros in this binary string and the number of ones. Okay, so some n0 and n1, this also has some n0 and n1. The innate, or the the inner inversions, those will remain the same no matter where I place it. But if I place it here, okay, let's call this 1 1 2 2. Okay, if I place this before, then inversions would be, otherwise inversions would be, so I want to take the minimum. Now I want to do this over all the strings. Now n times m is 2e5, right? What would be the best way? I guess what we want is number of ones to be minimum on the left. So let's just sort by the number of ones. Let's just sort by the number of ones, and then I order them like that. This can be just that sorting. I think that should be enough. Now is it, so what I'm thinking is to sort such that first of all what we want is n1 I to be less than n1 j. Otherwise if they're equal, then I want nj I to be less than n0 j to be less than n0 I to be less than n0 j. No, the opposite of this. So how can I do this? I mean, will this work? Let's say it has 3 5, and it had 4 100. So here, okay, this is 1 and this is 0, 1 and 0. So 3 times 100, it would give me 300, but 4 times 5 would give me 20. Spam call. Okay, no, all I care about, right, is just n0. Yeah, so I want to order it like n1i multiplied by n0j to be less than n0i multiplied by n1j. Will this sorting work? I had there was a similar problem in an AdCoder round which required this type of sorting. I never upsolved it, and that is why I'm suffering right now. So upsolve your contest, I guess. I have n strings, each of length m. Okay, let's make a vector pair for okay, so let's get auto x is equals to vi for auto c in ai. So if the character has a if the character is 0, then I'm gonna increase the first. So basically I'm storing number of zeros and ones, okay, and then I'm calculating that. First one represents zeros, second one represent 1. Now I'm gonna sort this array with this custom comparator x auto y, and the custom comparator is gonna be like this: return x dot second multiplied by y dot first to be less than x dot first multiplied by y dot second. So it comes at first only if the number of ones here multiplied by number of zeros is less than this, the opposite case. And then what can I do? What do I have to do? Okay. So I want to calculate the number of inversions, right? So first of all, let's calculate the inner inversions. What would be the inner inversions? Okay, so count 1 plus plus, and every time a 0 occurs, I add to my current inversions the number of times 1 has occurred. So basically, at this point, 1 has occurred twice. So for every 0, inversion will increase by 2. That's how I'm doing inversion. And now let's calculate the remaining inversions. So okay, so first of all, let's calculate the number of zeros in the entire combination. So I'm also gonna do this. So for integer I equals to 0, I'm just gonna do a loop n0 n1 in v. Let's reduce from the count 0 the n0, and then add to the answer n1 times count 0. Just calculating the answer, and then I can just print the answer, I think. Okay, seems to be working. All right, correct answer. Am I recording? My voice is audible as well. Okay, so far so good. So far so good. Where's water? Stay hydrated. It's very important in contest. I mean, there's nothing at stake here for me, but talking is pretty exhausting. I want to see my rank so I can clickbait. You know, I think my rank would be good enough to clickbait right now. Okay, I don't think 22 only. Oh no, I should be around here. So, oh, because I'm explaining. I was like, did I really do it that slow? And then I remembered, oh, I'm explaining. Anything for views, man. I'll take a hit in my rank for that. So Chef has numbers 1 to n. He wants to give exactly k of these numbers to his friends and keep the rest with him. He choose any k numbers such that GCD of any number from the chef's set and any number from his friend's set is equal to 1. So they are pairwise co-prime. Formally, suppose chef has set of numbers A and his friend keeps B, then this must be satisfied. So we want to construct a set. Okay. Okay, so if we want such a set, right? Let's say this is the initial set 1, 2, 3 up to n. Let's say this is the set A, right? So let's say I put one can go in any set, right? We don't care about it. Let's say I put 2 here. Then if I want, so I put 2 here, right? So I remove this. Now if I want every number here to be co-prime with this number, then what I'm gonna want to do is remove everything that is divisible by 2 from there to here. But then I will also remove a number like 6, which will then not be co-prime with 3. Okay. Okay. So let's see what the prime numbers are from here to here. Okay. Let's enumerate all the prime numbers. P. I'm not getting a number to put. PQ. Good naming. So let's say, so if I remove a set of numbers from here, right, then I'm essentially removing every number. I'm essentially removing some primes from this set such that let's say I'm choosing P1 and P3 such that all of their combinations raised to some power, right? K1, K2, they are less than or equals to n. I'm removing them. Or am I? No. No, I want GCD. What's my rank again? 22 is pretty terrible. Okay, 18. Much better. Much better. when a set of size k. For a set of size 1, we can always just remove 1. That is something. For a set of size 2, we can, okay. Okay, let's see what happens if I remove 2. If I remove 2, I remove 4 and 6. Because I'm removing 6, I also have to remove 3. Because I'm removing 3, I also have to remove 9 and then 12 and then 15. Because I'm removing 15, I have to remove 5. Kind of a snowball effect. Okay, I don't know what that means. I'm just saying whatever. Okay, it's like this. If I choose, let's say, some x, then I choose 2x, and after choosing 2x, the next thing that I'm gonna choose is the GCD of x and 2x, and let's say that is y. So I'm gonna choose all of the multiples of y, and it goes like this, goes here. Okay, so if this was 2, I chose us, let's say this was this, I chose 6. If I choose x, I have to choose 2x, and after choosing 2x, I have to choose, oh, after choosing 2x, I have to choose 2, right? Because 2 comes now. So after doing that, what I can do is, so now if I choose 2, I have to choose 4, 6, 8, 10, everything. If I choose 4, wait, does choosing 2 result in choosing everything? I think so. It's not that convenient. If I choose x, I have to choose 2x, then 3x, up to some kx. And if that happens, that means I'm choosing 2, 3, and k everything. So choosing some x means choosing not just x, 2x up to kx, but also everything related to 2, 3 up to k. Interesting. So what can we deduce? Is it tougher than what I'm doing? Okay, partition, it seems tough. Sum of n, k can be up to n minus 1. I got it. I think so. You know, if I am choosing 2, okay, so if I'm choosing 2, then I'm choosing 4, 6, 8, something like k times 2, right? That means it's a multiplier of 1, multiplier of 2, multiplier of 3, multiplier of k. That means I have to choose now multiplier of 2, multiplier of 3. So I've already chosen 2. So 3, 4 up to k. Now 3 can go up to some value, but that won't increase k. Because if 2k plus 1 is greater than n, then obviously 3k plus 1 is also greater than n. It's obvious. So the prime numbers, not prime numbers, but the numbers that I'll be choosing would not be what do we say, greater than k. What this means is there's only a few ways to choose. So one can go anywhere. Okay, I have 2, 3, 4, n by 2. This is important. And n. So all of these values, no, I'm only taking multiples. I have to take GCD as well. Okay, claim number 1, choosing a composite number means nothing. Why? Because let's say there are two prime numbers p1 and p2. If I choose p1 times p2, which is less than equals to n, right, it's a composite number, then this basically means choosing p1 and p2, right? So all that matters is choosing prime numbers. So now we all we care about is 2, 3, 5, 7 up to some prime number which is less than n. Okay, and then there's, okay, it's less than n. What am I writing? Okay, this is all less than equals to n. So whenever I choose a number, now the previous calculation, previous observations don't go in vain. Okay, this n by 2, let's say this is the line it draws. Okay, so if I choose any number, if I choose any prime number greater than this, okay, then that means I can just safely remove that prime number, because that prime number never got multiplied by 2. So all the prime numbers greater than equals to n by 2, sorry, greater than n by 2, sorry, they can be removed to our new set safely. However, if I try to remove anything else, okay, so if I try to remove any prime number below than that, then that would mean that 2 also gets triggered, because this would land here and 2 gets triggered. If 2 gets triggered, then so would be, and so would be every prime number below n by 2, because 2 times n by 2 is less than equals to n. So I can isolatedly choose any prime number above n by 2, but below or equal to n by 2, if I choose any prime number, I end up choosing everything as in all these prime numbers, right, and all the composite. Okay, so really the minimum size of, okay, so there are two sets, right, k and n minus k. So the size of other set can go from 1 to, let's say, this number of primes were p, okay, sorry, t, so t plus 1, so 1 to t plus 1. If k is within this much, I can build it, or if n minus k is of this size, I can build it. Alright, cool. I'm gonna copy this here. No, I don't want to see that. Is it visible, by the way? Should I make it bigger? I guess I can make it bigger. It was already bigger than my last challenge video. Go check it out if you haven't already. Forget contest, it's irrelevant. Okay, so test case is 4. Interesting. Why is n bounded by all test cases, right? They can just provide n as many times as they want, because my answer does not matter to that. Am I missing something? If I take any number here, 2 times 3 would land less than equals to n, and so all their multiples would. And this, if I take 7, again I go there, and again the chain continues. So the chain keeps on continuing, and yeah, nah, I'm right. Okay, so I'm gonna need sieve, linear sieve of Eratosthenes. Where's linear sieve? There it is. Const expression. It makes it a compile time constant. So n is 1e5. Okay. So I have prime numbers. And yeah, this works, I guess. I can't bother formatting it. So I take n and k. So now after n and k, I just need to know how many prime numbers exist greater than n by 2. Okay, so np is equals to, okay, let's do it simpler. So I'm gonna count how many prime numbers are greater than n that exist. Okay, so upper bound on primes and upper bound from n, right? So I get number of primes bigger than n that I have, and then I get number of primes that are bigger than n by 2. And now if I subtract, yeah, So number of primes would be r minus l, right? Sorry, no, what am I doing? If I have upper bound, I want to multiply, sorry, subtract it here. So this, okay, that didn't work out. This gives me the number of primes greater than n and greater than n by 2. Then this gives me prime in this range. Now if k is greater than equals to 1 and k is less than equals to np plus 1, then I'm gonna, so either this is the case, right? K1 n minus k, or I can just take minimum of kn and minus k, but I'll just do it like this, np plus 1. In that case, I'm gonna print yes, and then I have to print all the numbers. So let's see out one first of all. Oh, because I have to print these numbers, that is why they are bounding it by this. Okay, so let's store, let's just store all the numbers we had. So I'm storing all the numbers we had, and now okay, I can't be bothered. I'm just gonna say k2, k1 is equals to minimum k minus n minus k, sorry. Now if k1 and k1, so whatever, the smaller set, okay, I just want the smaller set to be in this range, and then what I can do is print yes. If k is equals to k1, then I can just okay, I'm gonna store another set or a vector integer p. Okay, and what I can do is b dot pushback 1, a dot erase 1, k1 minus minus. Now while k1 is greater than 0, I'm gonna, okay, integer I is equals to prime dot how is it? How do I do it? So I is equals to lower bound. I have to do it again. Okay, lower bound all prime numbers, sorry, upper bound, yeah, upper bound n by 2 minus begin prime. And now, so first of all I push b I'll do the printing later. Okay, I'll do the printing later. So first of all, I push B, erase A, push 1, erase 1, reduce it, get the I, and now while K1, I'm gonna say B dot push back, prime I, and then A dot erase, prime I plus plus, K1 minus minus. Now what this helps me achieve is two separated out sets, and now I can just say print yes if K1 is equals to K. What I'll do is for auto X in what was that? If K1 was K, then B. Yeah. Wait, I can just do then print B. Otherwise, for auto X in A, right? That is the bigger one. So if K1 was K, the set that we have to print, if that was the smaller one, then I'm just gonna print B because that's what we are forming. Otherwise, I'm just gonna print the remaining elements from the initial set, and that would be the answer. Otherwise, if that was not the case, then we just could not do it. I'm getting no everywhere. For your the only explanation is prime numbers being wrong. No. So L minus R. No, this is wrong. Two and three should be let's make it 10. Let's make this 10. So now the prime numbers I have are 2, 3, 5, 7. So 2, 3, 5, 7. Prime numbers greater than. Oh, okay. That is correct. That is correct. That is correct. So I have A and B. Oh, okay. So this was the reason. If K is K. This should do the trick. Yep, 1 and 3, 2 and 4. Okay, let's submit this and see how we did. Correct answer. Okay, did not expect it. And there are already so many submissions of it. I don't think I'm doing bad today. Yeah, even while explaining, I'm doing pretty okay. Alright, gonna stay hydrated. Wait a minute. Okay, never mind. I'm back and come on, update my rank. Oh wow, this guy is so good at this. Oh, I'll be around rank 5. That's nice. Oh no, never mind. 300 is a lot of people. Alright, string game. Alice and Bob are playing a game on a binary string S of length n. Alice and Bob alternate turns, with Alice going first. On their turn, the current player must choose an index I that is less than the final index n, such that Si is not equals to Si plus 1. That is why it cannot be the final index, and it is either I or I plus 1. So this reduces the length by 1 and the remaining parts are concatenated. The player who is unable to make a move loses. Determine the winner if both players play optimally. So, what is this question? They're playing on a binary string. They take an index such that, okay, this is the condition. This is not equal and erase either I or I plus 1 from the string. This reduces the length of S by 1. The player who is unable to make a move loses. Determine the winner if both play optimally. Okay. So a binary string is like something like this, I guess, right? So at every intersection, players can let's choose an intersection. Okay, let's choose this intersection. The first player makes a move and he can remove either this or this. If he removes this, okay, let's assume for a second this did not exist and this also did not exist. Let's assume. Then what happens is the first player has removed, if first player removes this, right, then the second player can remove this and win, because now the first player does not have a move. So okay, and meanwhile if the first player makes a move here, the second player has to make a move somewhere. So there's this thing that we have to worry about, this little part initially. and then also the other parts. Let's think it like this. So 0, if there is 0, I'm gonna call this an intersection where 1 and 0 intersect, are adjacent. So 0 intersections is a losing state. 1 intersections is a winning state. So if it is like this, currently there is 1 intersection, but removing this, right, does not reduce the intersections. So does this. Okay, so if I keep doing so, so what I can do is whatever one player removes, the other player. So first player removes this, second player will remove like maybe this. Okay, that was a very bad example. So if something like this, first player removes this, second player can either remove this or this. It really gets decisive around here. Right, now when the first player, so now when a player removes this, the other player can remove this and make the other player unable to move. Okay. Yeah. It's just whenever a player makes a move such that only one of the zeros or ones remain, then the other player can take advantage of it. As long as he doesn't do that, he will do that, and this will happen. This will happen for how many moves? So like at least 2, or if it's less than 2, and then this much moves it will happen. And after it happens for the moves such that state is like this, or either 0 is less or 1 is less, so it will happen. And then so if there was a state like 0 1, if 0 is 1s or 1 is 1s, okay, then player 1 automatically wins. Otherwise player 2 wins. Sorry, then player 1 wins. In this case player 2 wins. Okay, so we can simulate in a sense, like based on the parity we know which so if it is something like this, we already know who wins, the first player. If it is something like this, based on the number of zeros and ones, -2, we can figure out which player will be at this turn and then figure out the winner. So that is cool. We can figure out the winner for one intersection. What about the several others? Yeah, that's a pain. Okay, all right, rank. It is pretty good for me, who is pretty bad. How are my friends doing? Okay. Let's draw again. So if you notice, okay, if we look at this one, okay, if we look at this one, player one reduces it such like it becomes like this, and then based on whatever player 2 does, right, he can either remove this or whatever. So let's say he removes this, player 1 removes this, makes him unable to move here, and these two gets attached here, which does not change the overall parity of this, so doesn't change the overall parity of the winner even there. Okay, that is interesting. But what about this case? Removed, parity changed. Well, what a pain. What is division 2 looking like, by the way? What's this guy doing? Okay. How's this guy doing? Oh, he's not in. How are other people doing? How's my college doing? Okay. 56 solutions to string game? Partition, it has more solutions, so it has less solutions. Does this mean it is guessable? The final state would be like this, something like this. Yeah, final state would be either something like this or something like something like this. Wait, oh right. If I know what is the final state, What's the initial state? I can just subtract numbers, and then based on parity get the answer. But here's the problem, and the problem is there can be different final states based on what players decide to do. What will be the final state? I don't know. Mm. At every move, the length reduces by 1, and final state looks something like this. So what observation do I get? Both players are playing optimally. Mm. Wow, awkward silence, but I have no idea how to approach this. Wait, the final length of the string would be 2. Obviously, the final length of the string would be 2. 3, 4, 1, 2, 3, 1, 2, 3. Yes, that's right. So based on the parity, right, else I gotta check this. I mean, this would work. It passed samples. Did I say the opposite? Wait, have I not done the correct thing? Wait, I had not pasted the correct thing. I was like, why am I getting that? Now let's see. Yes, this is absolutely true. It's kind of a scam of a question if that's how it works. That's fine. This is better. Would have been pretty weird if that's how it was. Yeah, obviously. What if it is entirely 0 or entirely 1? As long as... okay. Alice going first. So Bob would win in this scenario. This is a scenario I didn't cover. So maybe, because multiple test cases are being checked, right? If x is 0 or n, then Bob wins. Otherwise, it reduces down to that. Yeah, fine by me. I cannot do this problem. This sucks. I don't have any approach. How do I even approach this problem? For length 2, so only remaining cases are 0, 1 and 1, 0. So here Alice makes a move, Bob cannot make a move. So Alice wins. So for this, Alice makes a move and Bob cannot make a move anymore. However, for greater than 2, it cannot reduce to, yes, it cannot reduce less than 2. Okay, let's try this. Fine by me. I don't know how to solve this. I'm feeling like giving up because the stakes are just too low. Stakes are just too low. People have done this problem. Oh boy. He directly did YACP. The last problem. STRADJ. I don't know how to do it. I'm thinking of just ending the screencast so that I can upload it right after the contest ends. That would be sick. Will get me more views, but let's try it again. If I cannot, I'll just leave. That's fine. How much view potential does this contest have? Let's see. That's a good number. That's another good number. Wow, 135 people did it. That's insane. How's this guy doing? Binary inversion, newbies. Yeah, we don't have newbies. Good. Don't be able to do strategy so I can feel better about myself. Let's change my approach to this problem. So this is one edge case that I've covered. This is another edge case that I've covered. Now, in all other cases, will the string length always go to 2? No, not if I don't even have to worry about this. Okay, so the thing is, if x is equals to 1 or x is equals to n minus 1, then Alice wins. Right. Otherwise this would happen. Am I just guessing this at this point? If 0 or n, then Bob wins. If 1 or n minus 1, that is an instant, win method. Otherwise, yes, otherwise neither of the player will want to touch two of them. Or what if it's like this, 1 0 1 0, 1 0 1 0. Yes, right. Whatever the player touches. Right. Perhaps. Maybe. I don't know. There's a lot of background noise of things moving. I successfully guessed the solution. That's how, ladies and gentlemen, you guess a solution. Not even close. Never doubted myself. Easy. Say it with me. Easy. I'm scum. Okay. Say it with me, people. Easy. That's how you guess a solution. Alright, friends. Finally, I can be above my friends. Well, this guy is so good. He solved the last two. I've solved the first four. Well, let's solve the special node problem. I'm feeling rejuvenated now. So this is a tree. Oh, sorry. This is a tree problem. So this would be good. I'm good at trees. It's nothing to do with the fact that trees are easier. So yeah, if you think trees are not easy, what are you doing? Trees are easy. There is a tree consisting of n nodes. A certain node x is marked as special, but you don't know x when we have to find it, and we can ask queries to find it. When we ask query y, you'll be provided with a random node on the path from y to x, including y. If y equals to x, okay, we won't get x. Okay, and we can only ask 12 queries at maximum. What is n? And if we get -1, that means we are at the correct one. It's not adaptive. X is chosen already. I have n is 1000. 2 to the power 12 is this. Okay. UIVI. Okay. So initially, my initial approach to this is like, let's say it's something like this. I choose any random vertex. Let's say I chose this vertex, right? And now obviously I don't know where it exists. Wait, a certain node is marked as special. Okay, now which node is special? Okay, so I know their numberings, right? So I choose any random node. 9. I choose any random node, and I will get something. I'll get a node that is in between from that node. Let's say 2. Let's say this is the actual node. I'll get something between this and this, but not this. So here's my solution. Whatever random node I guessed, right? Then whatever I get, just guess that. Whatever I get, so I will eventually reach it, but it can take on of time. But here's the deal. here is the deal. Okay. So whatever I choose, that is, let's say I choose y, and whatever the actual number is, I get x, right? I get, sorry, z number, right? Then z should be LCA of y and x. Not necessarily, but hear me out. So let's say I choose this and this. I will not get these values, right? I will either get this or this. So this will be LCA, but this will be not. However, if I take LCA of both of them, which would be this, okay, let's root the tree at 1 and query 1. When I query 1, I'll get some vertex, right? And by that I know in which subtree I have to go. Now what could happen is, let's say it was like this. It just I don't want to go there. Let's say it was something like this. It just keeps on going, and this is x. I first of all get 8, then 9, then in order of n times, and then I get x. So oh, isn't it just binary search? Okay, it's just binary search. Here's how it is. So by the first query, I get which of these paths it is in. So I get which of these paths is it in. So let's say I get this value. I jump here at least. And now, wait, I'll have to do it again. Okay, it is simple, I think, or maybe not. I'm gonna have to go for a little while. I'm sorry. I will put the timestamp in description. I'm back. And how have I fallen? Okay, cool. My rank has not fallen, which is good. I'll just try it for 20 minutes actually, because here's the thing. I also have to upload it, and because the screencast would be 2 hours long, the processing takes a lot of time. So I'll have to end it sooner than I want to. But yeah, that is the scenario here. Okay, so instead of doing like this, while I was away, I was thinking, let's query a leaf node. Now whatever value I get, right, then no, query this. Let's say it is here, and let's say everything has this. Okay. So, and it gives me this. Now I don't know if it is here or here. And how do I do this? We have to look on the diameter. So if I look at the tree from the diameter, okay, this can be at maximum 2, something like this. I query here. Wait, what am I doing? I query at the middle. I'll either get something in left or something in right. That would mean is, let's say I get this value, that would mean the answer is here. Do I recalculate the diameter? Why does it feel like taking the diameter works? So let's take a bigger diameter. 1, 2, 3, 4, 5, 6, 7, 8. I query here and let's say I get this, okay? So no. Yeah, it can be there. No problem really. Okay. So that means it's here. This much tree is cut. What did I do? So this much tree is cut. And I have to wonder if it is here. I can find the diameter again. So this is the diameter. And then I can ask here. Let's say I ask here and it says this. Then, Now what is the proof that it will do it in 12 queries? So in every query, it is removing at least diameter by 2 nodes. And you can argue that a diameter can be very small, right? So let's say I chose this diameter. I chose this as diameter. I ask here. And I get this. I won't get this. Here's the thing, right? I won't get this either. So actually, I remove. Okay, whatever. I remove around this. So whatever the diameter is, okay, this would get removed, would either answer me. Okay, so yeah, there it also gets reduced. I think it is diameter of tree. How to find diameter of tree? No, not binary tree. CP algo. Okay, this seems like a correct thing. I have no proof for this, but my intuition says, because there's some inverse correlation, right? That as the so first of all, take this graph, right? Take a linear graph. If I do here, I get this, I remove this, and then I keep going, right? And basically I remove half, right? So yeah, for linear it works. For then, however, for some extremely dense graph, also for a moderately dense graph, or let's just take a binary tree, right? I take this and I get something. So I ask here, it tells me here or here. I remove this much tree. I basically remove half the tree, right? More than half the tree actually. And then there was the star condition, which I get the answer in one go. So that's just my intuition. And also because n is 1000, so probably we want to find the diameter every time. Why diameter though? Isn't there anything else? Yeah, there isn't anything else. Reason being, I want some measure of the center of, because binary search is like asking in the center, right? I want some measure of the center, and the root is definitely not the measure, because if we take this, what is the quantity we know? Diameter. Let's take that. This is another guess solution, but there's still some strong intuition behind this if this works. The previous one, it had no strong intuition, that was just a guess. Okay, so integer diameter, I'm gonna take adjacency, and what is the current root? Okay, then let's get the furthest. Let's do this. Adjacency, new integer previous, and level. And I'm also gonna have something called answer. If level greater than answer dot first, if that is the case, and if level is this, then answer equals to level and u. for auto v. Otherwise I'm gonna get the furthest. Let's say this is getting the mid, right? 3 mid. Midpoint. Sorry. For let's say X. Who cares? So, no. Yeah. Let's DFS. Let's get the furthest from our root and use X. And then I'm gonna say y equals to x. X is equals to this, and then we get the furthest again from, but this time from u, which was y dot second. So we get the furthest again. Let's also integer get point. Wait, is there noise coming? Yes, so much noise. Wait, let me ask. Test. Okay. So I'm also gonna have a get point, which will just give me any point at some distance. Previous 0. If level is equals to a required, right, whatever required level is, whatever the required level is. So if that is the case, then the result is equals to u. Let's do the DFS. By the way, if this doesn't work, I'm not even gonna try anymore. I also have to upload the screencast. So adjacency v. Required, and then u level plus 1. One, two, return res. Okay. Integer distance is gonna be x dot y dot first divided by 2, and then I'm gonna say 301. Yes, and then I'm gonna say, and then I'm gonna say return get point adjacency from whatever I used earlier, but this time the distance is this much. Okay, so I can get the midpoint of a tree. Now every time I get a midpoint, I also have to remove it, so that's one other pain. Sorry, I'm using VLA, leave me alone. And now finally what am I gonna do? I'm gonna go ahead and yeah, do this while result, right? So I'm gonna see out yes. I'm gonna ask for this. Whatever output I get, battery is dying. Why is this not charging? Okay, now it is charging. I'm gonna ask for that, and then I'm gonna say result. Okay, next I'm gonna input that, and now I have to remove the vertex. Now I have to remove such that result. Wait, I think I found out the proof why this will work also. Now all I have to do is remove such that okay. So after I remove edge such that res to next is not possible anymore, then what I'm gonna say is res equals to midpoint, sorry, get tree mid. Okay, and that would be adjacency, and whatever is the new root. The new root is this. Cool. And then since you're doing okay, void blacklist. I'm gonna blacklist the vertices which are in towards the path of that. Okay, I'm gonna use boolean. Yes. And I'm gonna require a set blacklist, right? I'm just gonna call it s. Okay, what will happen now? So bool pause for auto v in adjacency u equals to previous, continue, otherwise okay. And what do I have to find? This is target. Target. So if it is, then we are gonna blacklist. V goes to previous, blacklist. Adjacency. Okay, and S, and then whatever the target was, now V and U. This is the case. I'm gonna insert and then return this. Now what I'll do is I'm gonna call this function adjacency as my target. My target is result, and U is next. Now for auto, now so V is less than V dot size I plus plus. Now auto V, if this is the case, if we count, so if there was an edge vertex with where we don't want to go, then we break. I'm just gonna swap this with size -1 and then just remove it. All right, so remove an edge and then do this, and now I have result. So result, let's draw 1 2 3 4 and 5, and let's say this is the solution. I mean that is the answer. Okay, 1 5 1 to 2 1 to 5 2 to 3 2 to 4. Now from 1 when I say 2, from 3 this seems wrong, but okay. 4 -1. What happened? Did I get the answer? Anyways, I'm just gonna say print. Okay, print tree. I want to know what the current tree I am at. Tree. Print tree result. Let's see what it is like. One, two, 1, 5, 1, 2, 1, 5, 2, 3, 2, 4. So 1, 2, 3, 4, 5. Okay. Now for 1 I said 2. Now I'm in 3 to 4. Oh, okay. This is the level, right? One to 5, 1 to 2, 2 to 3, 2 to 4. I say 1, I go to 2. I have 2, 4, 3. I say 2, I go to 4. I say 4, negative 1. Okay, next is equals to negative 1. Then I'm gonna break. Sorry. Then I'm gonna say out. No. Then I'm gonna break. Yeah. I don't know what I'm doing here. Wow. True. Right? Yeah, that makes sense. Then 1 to 2, 1 to 5, 2 to 3, 2 to 4. Okay, let's try this. -1 seconds? What? I have this remove. I'm using Intel. What is the problem? Hmm. Hmm. If count is 14, so I can make only 12. Then I'm gonna instead go in a runtime error because I want to see what's happening. Is it because I'm exceeding the limit, which is probably the case, but there's nothing to lose, so I'm gonna query. Has Doberman done it? He probably has. It doesn't seem like a very tough question. Okay, he hasn't. Huh. Assert false doesn't give runtime error? Try result 1. Okay. What is this? Get the furthest node from you and use X as that. Now why is that? X is again that, and get the furthest now from y dot second. Okay, this should be X dot first because I go to X and then from X, sorry, I go to X, I make it Y, and then I go to X, right? So I want the distance of this. I was only closing distance of this. Okay. Zero means that, 1 means that, 2 means 1. Okay, I want to see something real quick. So if level is 0, I'll get 0. Level is 1, I'll get 0. Level is 2, I'll get 1. Yeah. Level is 3, I'll get 1 again. Level is 4, I'll get 2. Okay. I don't think this is needed either. Okay, let's try that again. One, 5, 1, 2, 1, 5, 2, 3, 2, 4. At 1, 2, 2, 4, 4, negative 1. Okay, good. This was the problem. Distance should be the actual diameter, not half the diameter or whatever this y is, right? So I go from y dot second and make x. Okay, from y dot second, yeah, I go d. This didn't work either. Furthest level u. Well, I don't have any idea why it's not working. I kind of not want to leave already because I feel like I can solve it. So here's my idea, right? So first of all, I go to this vertex and then I tell, okay, yeah, this can have 3 more. And then something like this. I mean, thing is, it should work out. Thing is, it should work out. I don't know, man. I'll just do this. I'm also feeling hungry right now. So that's that. Well, that sucks, I guess. Well, one thing I can try is obviously this. Maybe this will work. Who knows? Yeah, that is it. What does my rank look like? Yeah, pretty bad. People have done, so many people have done 5th. Okay, not many people have done 5th. 1, 2, 3, 4, 5, and maybe some people. Yeah, but many people have done 4th, and I was pretty slow. What am I missing? Well, this just seems wrong. Oh no, I'm gonna have to cut hide. Oh, nice save. Nice save. Okay. This should give me a runtime error. And now, what can I do? Let's see. Am I getting -1 there? How will I get -1 there? Heck if I know. So much noise. Okay, that is it for my screencast. I don't think I'll be able to solve this problem. I also have to get this up quick. Let's have a look at B. What is this? Find the special node problem. Did we have this? Oh no, this is the problem I'm doing. I couldn't do it. 12 people in division 2 did it. Sad. So yeah, that is it. Final rank list. Rank 16th. Pretty bad. And bye.